Have you ever noticed how sometimes our weather seems to get stuck, bringing unusually long stretches of heat, cold, or heavy rain? You might be wondering what could be causing these more extreme and persistent weather patterns. One major factor contributing to these significant shifts is a change in a powerful river of air high above us, known as the jet stream. This fast-flowing current of air, encircling the globe, is becoming wavier, and the primary reason for this change is the rapid warming of the Arctic region. The jet stream's strength and path are primarily driven by the temperature difference between the cold Arctic and the warmer mid-latitudes. Think of it like a river flowing downhill, where the steeper the slope, the faster the water flows in a relatively straight line. Historically, the Arctic was much colder than regions further south, creating a significant temperature gradient that kept the jet stream strong and relatively straight. However, the Arctic is warming at a rate 2 times faster than the rest of the planet, a phenomenon known as Arctic amplification. This dramatically reduces the temperature difference, weakening the slope that drives the jet stream. As it weakens, the jet stream becomes less like a straight river and more like a meandering one, taking larger, slower loops. This wavier, slower jet stream has real-world consequences for our daily weather. When the jet stream develops these deep meanders, weather systems tend to get trapped within them, leading to prolonged periods of specific weather. For instance, if a high-pressure ridge gets caught in an upward bulge, it can lead to extended heat waves or droughts. Conversely, if a cold trough dips south, it can bring persistent cold snaps and heavy precipitation to certain areas. Understanding these changes helps us anticipate the potential for more extreme and stagnant weather events in our communities. Scientists often refer to these atmospheric waves as Rossby waves, and the Arctic's disproportionate warming is directly influencing their amplitude and persistence. This connection highlights how localized climate changes, particularly in sensitive regions like the poles, can have far-reaching impacts on global weather systems, affecting agriculture, infrastructure, and everyday life in distant regions. So, when you hear about record-breaking temperatures or unusual amounts of rain that just seem to linger, remember the Wavier jet stream. It is a powerful illustration of how interconnected our planet's climate systems truly are, and how changes in one part of the world can ripple out to affect us all.